Welcome back to the deep dive. Look, if you're a professional working in data management right now, if you're the one architecting schemas, wrangling features, maybe trying to figure out why those cloud bills keep climbing, well, this deep dive is absolutely for you. We're not talking about small tweaks here. We're diving into something pretty big, a really profound transformation that's quietly reshaping data architecture across the board.
That's spot on. What we've found, digging through the research, is that AI isn't just, helping out with traditional data modeling. It's actually dismantling it. It's rebuilding the core processes, the sequential steps we've relied on for decades. Think about that classic three-tier approach, conceptual, logical, physical. Well, AI-driven automation is basically making that obsolete. It's becoming much more dynamic.
Okay, so the old blueprints are out. We're looking at a new paradigm, right? A system that's always adapting, not just built once. So our mission today, let's really unpack this new way of working. What does it mean for data professionals strategically? Okay, let's get into it. And maybe the best place to start is where the change is most obvious. Just sheer speed.
Yeah, the speed increase is usually the first thing people notice. It's a big clue. The whole operating model shifted. The sources are calling it the rapid acceleration phenomenon. Think about conceptual modeling historically. That's been a massive bottleneck, hasn't it?
Oh, absolutely. Weeks of meetings, whiteboarding, back and forth with stakeholders, just trying to translate business needs into something technical.
Exactly, the part everyone kind of dreads. That whole phase. Now it can be compressed, potentially down to hours.
Hours from weeks. How?
It comes down to something the research calls the text-to-schema paradigm.
Mm-hmm.
Basically, it uses generative AI and natural language processing. You feed it complex business requirements, could be spec documents, user stories, even just high-level goals.
Mm.
And it spits out a foundational entity relationship diagram, an ERD.
Wow. Okay, so that just vaporizes the blank canvas problem. But for the experienced architects listening, it's not just about drawing boxes faster, is it? It's getting agreement faster, getting sign-off.
And that's the key benefit, really. The ROI comes from accelerating that stakeholder validation. Because it generates a pretty decent first draft almost instantly, you can get feedback much, much earlier.
Hmm.
And that tackles that huge pain point, those really costly schema changes that always seem to pop up late in the game. Catching misalignment early saves a ton down the line.
Which implies the role of the data architect itself is changing. Pretty dramatically, it sounds like. You're not spending all your time translating meeting notes anymore.
No, the function is fundamentally different. You're moving away from being the manual drafter, the primary interpreter. The sources describe it as becoming refiners and governors of what the AI suggests. The AI does the heavy lifting on that initial concept. The human expert focuses on refining it, ensuring it aligns, checking compliance, making sure it fits the bigger picture. You're supervising the output, not creating it from scratch.
Okay, that makes sense for the conceptual part, speeding things up, changing the architect's focus. But you mentioned AI is restructuring things too, and that brings us to the logical layer. This is where you said it gets really interesting, right? This hidden bifurcation.
Yes, this is a really profound shift. At the logical level, we're seeing the traditional single model effectively split into two parallel blueprints.
Hold on. Two logical models. The whole point of logical modeling was always unification, consistency, right? A single source of truth. Isn't creating two models just doubling the complexity, doubling the maintenance headache?
That's the immediate reaction, and it's a valid concern. It does add structural complexity. But the research argues it's necessary. It's driven by the very different needs of traditional BI and modern AI workloads. Trying to make one logical model serve both just doesn't work well anymore. They have conflicting requirements for performance, granularity, consistency.
Okay, I can see that. BI needs stable, aggregated views. ML needs raw, granular data, maybe specific feature calculations.
Precisely. You can't optimize one model for both effectively. So you trade that old simplicity for specialized performance and better integrity for each purpose.
All right, so walk us through the split. What are these two blueprints?
Okay, so the first one is probably more familiar. It's the semantic layer. This is still that business-facing abstraction layer. Its job is consistency for BI tools, for self-service analytics. It translates the underlying technical stuff into terms that business understands: customer, product, region, whatever. It prioritizes human understanding and stable metrics.
Right, the classic BI semantic layer. Got it. What's the second one?
The second one is the newer piece, the specialized logical feature model. This one is built and optimized specifically for machine learning operations, MLOps. It's not managing broad tables so much as it's managing very specific, often derived values, the features that models consume. and these live within dedicated feature stores.
Feature stores. Okay. We hear that term a lot. Why does ML need this separate, specialized logical model built around features? Why not just pull from the semantic layer or the raw data?
It's all about integrity, versioning, and reproducibility for MLMs. Think about it. If a data scientist builds a model using a feature like, say, average customer purchase value over the last 60 days, that exact calculation, how it was derived, needs to be locked down, versioned, documented, and easily reusable by other models, other teams. You can't have ambiguity there.
Ah, I see. So the feature store and its logical model guarantee that average purchase value means the exact same thing every time it's used, and you know which version you're using.
Exactly. It manages the features, their lineage, their metadata. It ensures versioning and reuse. That's absolutely fundamental if you want reliable, scalable, and reproducible machine learning in production.
Okay, so we have these two parallel logical blueprints, one for BI consistency, one for ML reproducibility. They both stem from the same underlying raw data, but they serve different masters. Managing that sounds tricky.
It is, and the sources are really clear on this point.
Good.
You need integrated management platforms now. You have to govern both logical models together, keep them synchronized with the physical data, track lineage across both. Otherwise, you risk divergence, data integrity nightmares, inconsistent results. It demands better tooling.
Which brings us nicely to the physical layer. We've talked concepts, logic. Now let's talk about where the rubber meets the road, especially in the cloud. Because physical architecture isn't just theory anymore, is it? Design mistakes hit the bottom line instantly.
That's the crucial link now. With consumption-based cloud platforms, every physical design choice has a direct financial impact. And in the AI era, physical modeling isn't a one-time deployment step. It's becoming this continuous dynamic optimization process. Often AI itself is managing it, things like indexing, partitioning, resource allocation, even query tuning, all happening on the fly based on how the data is being used.
Right, the platforms are getting smarter. But you're saying that automation actually makes cost governance more critical for the architect, not less.
Absolutely. Because if those automated optimization systems get it wrong, maybe they over-provision compute clusters for simple queries, or choose inefficient storage tiers, your costs can just explode without warning. So the physical modeler's job shifts. It's less about manually placing tables and more about choosing the right architecture and configuring the system to minimize data movement and prevent runaway compute spending. Cost becomes a primary architectural driver.
And that leads into something pretty alarming. The sources mentioned this idea of double-dipping charges. If I were an architect hearing that term, I'd be worried. Sounds like an easy way to blow the budget.
It's a huge ROI killer. It happens when you have, say, your main data warehouse or lakehouse here, and then a completely separate specialized ML platform over there, maybe something external. To train a model, you have to pull data out of the warehouse, paying compute there, potentially egress fees.
Yeah.
Then you push it into the ML platform and pay for compute again to process it there, plus maybe data access charges on both sides.
Wow. So you're essentially paying twice for the compute on the same workload just because your data and ML tools are in different silos?
That's exactly it. And honestly, this economic pressure is probably the single biggest driver forcing architectural consolidation right now. Teams are moving rapidly towards unified platforms that bring storage, data processing, ML tooling, and governance under one roof. Why? To kill those multi-compute penalties and keep data movement minimal. It's driven by financial necessity.
Okay, architecture, costs. It all feeds into governance. And if the systems are dynamically changing themselves, splitting logical models, the old way of doing governance, like auditing after the fact, that just breaks down, doesn't it?
Completely. Governance has to flip. It can't be retrospective. It has to be proactive, built-in, real-time prevention.
So what does that look like? What's the scope of this new data governance for AI, as you called it?
It's much broader than traditional governance. It's not just about table permissions anymore. It has to cover data quality, regulatory compliance, yes, but also crucial ethical considerations, so things like bias detection, fairness checks, and security, of course. And critically, this applies across all the AI assets. Not just the final model, but the features used to train it, the code, the pipelines that run it, all the intermediate steps. Everything needs governance.
That sounds like a massive undertaking. How do you even track all of that?
The engine driving it all is high-quality metadata, rich metadata. AI can't automate schema suggestions or optimize queries or track feature lineage unless it has detailed metadata to work with usage patterns, data profiles, schema histories, transformation logic.
Right, metadata becomes the fuel for the whole automated stack.
Absolutely. Without comprehensive metadata, you're flying blind, which is why automated lineage tracking is no longer a nice to have. It's mandatory. And it needs to be real-time, granular, down to the column level, and it has to track lineage not just across tables, but through complex transformation jobs, notebooks, feature calculations, the whole life cycle.
You mentioned ethical considerations like bias. How does something technical like metadata actually help govern something like fairness?
It becomes the mechanism for enforcement. So imagine you have a governance rule. No models predicting loan approval can use features derived directly from sensitive demographic data. If your metadata captures the complete lineage of every feature showing exactly which source columns and transformations created it, the system can use that metadata. It can automatically flag or even block a feature during development or deployment if its lineage violates that rule. Before it gets baked into a model, it moves compliance from a checkbox exercise to an automated control.
That makes sense. Proactive, automated enforcement based on lineage. So with all this automation, conceptual design, physical optimization, even some governance checks, what does this mean for the skills needed? What does the data professional actually do day to day?
Yeah, it's a major skills revolution. Sources are pretty clear here. Demand for purely manual drafting skills, the deep requirements gathering. That's waning. What's becoming critical are skills in MLOps practices, understanding and managing feature stores effectively, knowing how to implement and monitor these AI governance frameworks. Success isn't about designing the perfect static model by hand anymore. It's about your ability to configure, monitor, tune, and govern these incredibly powerful, hyper-automated systems. The data professional, in many ways, becomes more of an orchestrator of these automated processes.
An orchestrator. I like that. Okay, so let's bring it all together. For the data engineering leaders and architects listening, facing this shift right now, what are the absolute must-do strategic imperatives? Where should they focus their energy and investment immediately?
Based on everything we've seen, it really boils down to three core investments that are pretty much non-negotiable now.
Okay, let's hear them.
First, invest immediately in unified governance platforms. Seriously. It's the only practical way to get rid of those double-dipping cost penalties we talked about. And it's essential for providing that end-to-end cross-system lineage that AI compliance, debugging, and auditing absolutely demand today. Trying to stitch together separate tools is becoming untenable financially and technically.
Okay, unified platform. Got it. Number 2.
Second, formalize and govern your feature stores. Now, don't wait. Treat features as first-class citizens. Implement centralized shared feature stores with strong governance around quality, versioning, access control, and metadata. This is the absolute bedrock for reliable, reproducible, and scalable MLOs across the organization. Ad hoc feature engineering just won't cut it anymore.
Makes sense. Build that feature foundation properly. And the third.
Finally, number 3. Implement rigorous, continuous monitoring of the AI systems that are doing the optimization, especially the physical optimization linked to cloud costs. You need transparency. Are those automated performance gains actually translating to positive ROI? Or are they accidentally creating resource black holes that are burning through your budget? You have to watch those automated systems closely.
Right. Trust but verify, especially when the system holds the purse strings. So the takeaway seems pretty stark. This isn't some future trend. It's here. It's operational. The old ways of sequential, manual data modeling are being actively replaced by these automated, dynamic, economically aware systems.
Exactly. And maybe the final thought for everyone listening is this. The organizations and the professionals who will thrive in this new landscape are the ones who recognize that AI-driven data modeling isn't just another tool to make the old process faster. It's a genuine paradigm shift. It demands entirely new thinking about architecture, about governance, about cost management, and yes, about the skills needed. Trying to ignore this or just layer AI on top of the old ways, well, that's a fast track to becoming economically unsustainable and finding your own skills rapidly outdated. The change is fundamental.